were twice washed and supplemented with 2% of wheat syrup brown of source of carbon to study the impact of incubation period on bacterial growth. The bacterial number was counted along 96 hours. Different pH values from 5 to 9 were adjusted into 0.1 more hydrochloric or sodium hydroxide to check influence of pH. The calcium nanoparticles were prepared from calcium chloride using mechanical milling by metal balls as previously described, and chloride was then dried at 150 degrees in the hot air oven. After 2 hours, calcium nanoparticles were synthesized by using SPECS instrument with the weight and ball of tungsten carbide and ball to power rate of ratio 10 to 1. The crystal structure of the synthesized sample was determined using X-ray diffraction analysis, which utilized a copper potassium alpha radiation source. The synthesized nanoparticles were characterized through transmission electron microscopy and Fourier transform infrared spectroscopy. To evaluate the minimal inhibitory concentration and bactericidal concentration of nanoparticles on the growth activity of isolated cellulotic bacteria and microdilution technique. The bacterial cells were previously cultivated at 35 degrees by pH 7, sunoacidic, at rotation 120, and the bottles of 20 milliliters were flushed with hydrogen to fulfill anaerobic conditions. Then the batch experiments were conducted in working volume 1 conducted in this working sterilized bottles, and microorganisms were prepared and supplemented. The bottles were tightly sealed and sterilized are airtight rubber caps and paraffin. Then they were incubated in dark orbital shaker 120 rotors per meter at 37 degrees. The concentration of hydrogen was gas chromatography with thermal conductivity detector. The cases were collected and estimation hydrogen and reducing sugar. Determination of hydrogen chloride and nanoparticles on the biohydrogen were checked by adding inside bottles as to supplement with wheat bran 0 to 80 micrograms of nanoparticles and simple calcium chloride. Also were triplicated, and this saccharification was made by checking the volume of fermentative sample were contacted and combined with 2 milliliters of dinitrosalicylic acid after heating the tube of boiling water bath for 10 minutes. That absorbance of each sample was measured at 540 nanometers. The quantity of saccharic 30% was proportional to reduced sugar and conversion to initial weight blend. Energy conversion was using a formula that proportional to heating values of hydrogen and contrary to the heating value of substrates. The statistical analysis was performed during another test. Isolation method compared chains and was as Rhodos Rosolomorea marislavi with 99% productivity. The exponential was investigated to determine optimum catabolic enzymes. The results showed that optimal growth was detected at on 20 grams of wheat bran at pH 7. So not acidic, so should be later. The acidic pH 5 attributed significantly decreased the bacterial number and increased while hydroxide decreased. The particles spherical variable size, the results X-ray diffraction was obtained, and the crystallized size of was proportional to correction parameter and length, and contrary proportional to cosinus of light of XRD fraction. And as a result of hydrogen production, it shows that in case of using of nanoparticles, there was hydrogen production was 150 milliliters per milliliters of waste, while in case of in case of chloride was just 100. So to one half was increased, and the highest was after 20 milligrams per liter, and the lowest hydrogen production was similarly like in common practical research, not like a planet Earth, where the lowest was 10 and then higher. So we can see that wheat bran also is optimum value of 220 gram per milliliters, while other is less. As a result, we see also that saccharification increased when by 10 of only 10% in case of nanoparticles, so it happened. As a result, we obtain the effects of supplementation with C. As a result, we compared nanoparticles of sodium chloride, and we see that efficiency yield was 50% if nanoparticles in case of only glucose, and 33 in case of wheat bran, which is similarly, it's not so high like iron and but glucose, but higher in case of nitric oxide, nickel oxide, titanium oxide. And we see that the trouble is not many field is about full scale, so full waste is needed to check. In the current study, the cellulose, the composite material was identified uh, mm, bacteria called Rosomaria marislavi, and this showed that it improved the high level of high production for wheat bran by produce medium containing by 20%. The result of carbon oxide nanoparticles were leading to higher yield production, and this showed that can be used in both nanoparticles of calcium and per treatment cellulose is useful. And thank you very much for listening.